Hi guys, hope you all are doing well. Welcome to my channel Python Short. Today we'll be seeing how to design a logical NOT gate using a simple neural network. So first let's see how a NOT gate looks like. So this is a simple NOT gate where my input, if it is X, then output I am getting as X bar. That is nothing but it will just negate the value of a input. So this is how a truth table of my NOT gate looks like. When my input is 0, the output is 1, and when my input is 1, the output will be 0. So it is simply negating the values of the input. Now here, to design a neural network for any logical gate, there is a concept called as perceptron. As I have explained this in earlier lecture also, perceptron, this is nothing but a simple neural network. Okay, simple ANN, artificial neural network, which has inputs, say, and outputs. So earlier for AND gate and OR gate, we were taking inputs as 2 and output as 1. But here we have one input and one output. Again, we say that this NOT gate is a linear model. Why? Because here we can easily or linearly model, linearly separate between the outputs. So for that, the equation we know is y equals to mx plus c for linear model. My m is nothing but weights here and my b is nothing but biases for output. Now as we have only single input, so we will just take this equation as it is. Not like AND gate and NOR gate, not like AND gate and OR gate which we have explained earlier where we have x1 w1 plus x2 w2 because there were two inputs there. Here we have a single input, so just let's take this value. Now for perceptron we know the output formula. We get output of 1 if and only if this condition, this is nothing but wx plus b here is greater than 0. Otherwise, we get the value as 0. Now to design a neural network for this condition, what we can do is let's do the calculation. Before that, we need to set some value for W and B so that these conditions becomes true. So you can try different values and see and check the equation. Here I'll directly come to the solution. So when I set weight to be a -1 and then when I set my bias to be as a 0.5, that time usually this equation satisfy. Let's see. Here I'll write my x, here I'll write sum. This is nothing but what? Wx plus b calculation, and here will be my output. When I put these values into this equation, what I'll get equation as y equals to 1 if my w is -1, right? So minus x. Bias is what? Plus 0.5 is greater than 0. So this is my equation. This is my sum which we will be calculating here. Okay. So here when the input is 0, my sum will be what? X is 0 minus 0 plus 0.5. Answer is what? 0.5, which is greater than 0. My output should be 1. Then when my input is 1, then what happens is -1 plus 0.5. This is minus 0.5. Less than 0, my output is 0. You can see x is 0, then output, that is nothing but y, becomes 1. And if it is 1, this becomes 0. So this is how a simple NOT gate can be designed using a simple perceptron here. So basically here will be my input, that is nothing but x, and then we get directly output where I am setting my W as -1 and my bias as 0.5. So this is how a perceptron model will look like for NOT gate. I hope this is clear. So this is how you can design a various logical gates using a simple neural network. So till now we have seen AND gate, OR gate and a NOT gate. In next lecture we'll see how a XOR gate and XNOR gate are designed. Those are a little bit complex, so I'll recommend before going to those gates you just see the videos of AND gate and OR gate for more clarification. So this is all. If you like this video, please subscribe and keep sharing. Thank you.